46 is on projectile motion with parametric equations. So we already did parametric equations. That was when we had like x equals an equation with t, right? Y equals something with t. And now we're going to put this together and we're going to do projectile motion. So if you recall, projectile motion is when we have those parabola shapes, when we like launch something into the air. So if I hit like a golf ball into the air or throw a tennis ball or whatever, these are all projectile motion, okay? And they have a horizontal component and a vertical component. So it says, that's what it's saying here. So it says, why do we use parametric equations? So an example is projectile motion. So it says, suppose we're throwing a rock straight into the air with a velocity of 35 feet per second. If you didn't have gravity, we would compute how high the rock would be after the following amounts of time. So if we didn't have gravity, after 0 seconds, we'd be at a height of 0, right? Well, from the ground, right? And then after 1 second, I'd be at a height of 35. And then after 2 seconds, I'd be at a height of 70. And after 3 seconds, I'd be at, you got it. All right, but we know that that's not how, these situations really work. So when we have gravity, things are coming back down. Now, if we were on the moon, there's still a little bit of gravity, but it would come back down a little bit slower, right? So on Earth, our gravity is negative 32 feet per second squared, or negative 9.8 meters per second squared. You might see physics classes use negative 10 meters per second squared. That's kind of an approximation, okay? So we're going to use one of those two gravities, depending on if our problem has feet or meters. Okay, so we always got to look at that. And the equation ends up being that our height is equal to 1/2 of whatever our gravity is, times t squared, minus, well, plus, actually, the initial velocity times t plus the initial height. So I'm going to write v sub o and h sub o for initial velocity, initial height. Do you guys understand that? Subscript of 0. We've done that before. Okay, so in our case, we're starting it at a height of 0. And if we didn't have gravity, right, this part would be gone. Right? If gravity wasn't there, we would just have, whatever our time was, like we just did, multiplying by 35 or whatever. All right, but we do have gravity, so we got to consider it. So we're going to use the equation h of t equals 35t and then minus 16t squared. Do you guys see where the 16 comes from? It comes from that 1/2 of gravity. Half of gravity, half of negative 32 is 16, negative 16. All right, we're going to plug that in. So you could do a table on your calculator if you want to. That's probably the easiest way to do it. So I'm going to do 35x on my table minus 16x squared. And then I go to my table, and I can put in those values. I can put in 0, 1, 2, 3. How do you do the table? You do second, and do you see the graph button on the upper right? Do second table. Okay, so after 3 seconds, it says we're at negative 39 feet. What does that mean? Yeah, so if you go to your, I'll do it on here. So if you go to your calculator and you go to y equals, you can put in your equation, which was the 35, and on your calculator you can just hit x minus 16x squared. And then when you go to table, it will already have values on there for you, like 0, 1, 2, 3. But some of you that were in my class last semester, you don't have values there, right? Because we've already done something fancy to our calculator. So Anna Catherine, if you do second, and then above window it says table set, so hit that button. So second and then table set. You can make it so that your independent says ask. And then when you go into your table, it's just blank, and you can put in whatever values you want. So this is like a t-table that your calculator does for you. So whatever value you wanted for t, you can put it in, and you get all those values. Does that make sense? Does everybody have that? Okay, so what does it mean if I'm at a height of negative 39? Did my golf ball, or whatever this object is, did it go into the ground? No. Well, it seems like it did. It's at negative 39. What happened? It hit the ground somewhere between what? What two times? Between 2 and 3 seconds, right? And you can find that. You can plug in 2.5, 2.6, 2.7. You can try to figure out where that is, okay? All right. What if I wanted to find where it hit the ground mathematically, right? If I didn't want to do, so you could find a pretty good approximation. I could do 2.5, and I could say, oh, that's still negative, so it's got to be somewhere between 2.5 and 2.0. Oh, still negative. How about 2.2, right? You could do that. And you could keep approximating on your calculator, but what would be the mathematical way to find when a rock hits the ground? How did you know? Just thinking. I can see the think in your face. You're finding when the height equals 0, right? Do we have the height equation? Yeah. So we set that equation equal to 0. So we're going to say 35t minus 16t squared equals 0. And we solve it. Okay? This is actually a pretty easy one to solve because we have a common factor of t that I can pull to the front. So I'm going to pull a t to the front, and I'm going to have 35 minus 16t equals 0. And I set both of them equal to 0. So if I set 35 minus 16t equal to 0 and solve, I get 35 over 16 equals t. And you could find a decimal approximation for that. It'd be 2.1875 seconds. Right? Much faster than doing the table and being like 2.1, 2.2, 2.15, 2.16, right? It would take forever to do that. Okay, got it? Okay, so what else are we going to find? So it says, now suppose that we don't throw the rock perfectly vertical. So that was assuming we throw the rock up, and it goes up above us, and then hopefully we move out of the way, and then it falls down, right? If we're throwing it at an angle, and this is what I was trying to preview last time, we have a vertical and horizontal component. So we have our initial velocity, like our v sub o from before, which I'll just call v. And we have a horizontal and a vertical component for that. So I'm going to call it v subscript x and v subscript y. Okay, and our initial velocity was 35 feet per second. And so this says, well, what if we throw it at an angle of inclination of, what did it say, 30 degrees? Could we figure out v sub y and v sub x? It's really nice that it's 30 degrees because we could use a 30, 60, 90 triangle, right? Or we could set it up with SOHCAHTOA. Did you guys forget your 30, 60, 90 triangles? So let's say I want to find v sub x. This is adjacent and hypotenuse, right? So we're going to set it up with cosine. So we're going to say, well, that means the cosine of 30 degrees equals v sub x over hypotenuse. So we get v sub x equals 35 times the cosine of 30. And v sub y, well, that's going to be sine of 30 equals opposite, which is v sub y over hypotenuse. So we end up getting v subscript y is equal to 35 sine of 30. Does this kind of look familiar? This means that our velocity has an x component and a y component. The x component is 35 cosine of 30, and our y component is 35 sine of 30. Is this kind of ringing a bell? Do you guys remember the airplane stuff we did? Do you guys remember how we had like the magnitude times cosine of the angle, magnitude times sine of the angle? That's what we're doing. That's the same thing. We're getting an x component and a y component. All right, so it means our height equation, our initial velocity isn't actually 35 because that 35 is going in this direction. So part of that is like a force going that way, and part of it is a force going upwards. Okay, that's what the x and y components mean. So our initial velocity in our y equation isn't just 35, right? So we're going to start out with our negative 16t squared from the gravity, right? 1/2 gravity squared times t squared. And instead of having initial velocity of 35, we're going to have 35 times the sine of 30. That's our number, right? Whoops. Times t plus our initial height. So I think our initial height was 0, right? Did I still say 0? So plus 0. So that was our initial height, and this is the initial velocity in y direction. Do you know what I mean by that? So going upwards. So part of that force, when we throw something like at an angle, part of it's going up and part of it's going out. rest of the t is super simple. Because here's what happens. If I'm throwing a ball, if I was throwing something horizontally, it's going to continue to go horizontally forever and ever and ever and ever. Except what really happens in real life is that the horizontal component eventually ends because the vertical component hits the ground, right? So if I was throwing a ball and there was no gravity, it would just continue going forever. Okay, so it's going to look like 35 cosine of 30 for every single second, so times t. Are you with me? Kind of weird. All right, so find when the ball hits the ground. So if I'm finding when it hits the ground, I want to find when I have my height equaling 0. So I'm going to set my negative 16 t squared plus 35 times sine of 30 times t, don't forget that t, that's what I always forgot when I was in school, equal to 0. Write something today? Do you need a pencil?
No, I don't
Oh.
have anything.
And you got are you lefty or you're righty?
Oh, righty.
But you need a pencil. Oh, it's a crusty one. That was really gross. They're all crusty. Anybody got a nice pencil for Kate here? Oh, here's one. The first one I pulled out, it was not sharpened and it had cobwebs all over it. All right, this one's pretty easy to get t by itself. Do you guys remember what we did the first time? Yeah, you can actually pull out that t. Do you guys see why it would be a little bit harder if we did have an initial height? If we had an initial height, then we'd have to use the quadratic formula or our calculators. You will get to use your calculators. So we're going to set it equal to 0, so negative 16t plus 35 sine of 30 equals 0. So I'm going to take that 35 sine of 30, make sure you're in degree mode. So if I subtract it over, I have my negative divided by negative 16, so divide by 16. So I get, oh, I asked you to make sure you were in degree mode, and then mine was in radian mode. That's why my answer was negative. It doesn't make any sense if it's negative, right? So did you guys get like t equals 1.09 something, 375? But we also have t equals 0. Why do we have 0? So it says, when does the ball hit the ground? It says at time 0. Because it started on the ground, right? What if I started on the top of a building and I hit a golf ball off the top of the building? We would get a negative answer for our t. So we get a negative 1 and a positive 1. Does that make sense? Do you guys get that? Okay. All right, so when does the ball reach its maximum height? So when you have a parabola and you're trying to figure out its maximum height, we can do this a couple different ways. We could use our calculator, right, to find a maximum. We just found that we started at time 0 and we ended at 1.09375. What do you guys think the maximum height would be? It'd be right in the middle. We could divide by 2. It ends up being at 0.546875. I could round to 3 decimals too. That's when it's going to reach its maximum height. What's the problem with only knowing this method, though? Yeah, if you start up here, right, then we have an issue. Because it's not going to be directly between here and here. It would be between whatever value you found before and here. So it's a little tricky, right? So what else could we use? We could use something we learned in Algebra 2. T equals negative b divided by 2a. Do you guys remember that? That would find it as well. Okay, and we'll do some then involve that. All right, so that's when it reaches its maximum height at that time. So t equals. And then, of course, it probably will say next, what is the maximum height, right? So if you were asked to find what is the maximum height, what would I do with this number in order to find what the maximum height was? And then plus this, right? So you'd have to plug it back into the entire height equation. So you'd plug in negative 16 t squared. That's when you could use that table if you've already put it into the table and just plug it into that table. Make sense? Okay. All right. Bill. guessing you've played football before. Have you played football before? I know you're a very good soccer player, right? But don't you play soccer? You don't play soccer? Okay. So Bill plays football for the first time with his friends, and he realized that he's a natural at field goals. So he practices kicking the football 35 yards, which is 105 feet. Do we all know that? Times 3, right? From the goalpost, which has a crossbar that is 10 feet high. If he kicks the ball with an initial velocity of 65 feet per second, it's really fast, at a 36-degree angle of inclination from the ground, will he make the field goal? All right. I don't know. We got to figure it out. So we're going to see. So we're going to do our vertical and horizontal components of the velocity. So here's how we start our problem. So we say we have 65 feet per second at an angle of 36 degrees, which is going to give us a vertical and a horizontal component. Okay, so we end up getting that our v sub x is equal to 65 cosine of 36. Do you guys know where I got that? And our v sub y is going to be 65 times sine of 36. So we get parametric equations, right? So our two equations together involve our y equation and our x equation. And let me do the x first. Seems weird to do the y first, right? So our x equation and our y equation. The x equation is the easy one. That's the one where I was saying he's going to kick this ball. It's going to go horizontally forever and ever and ever if there was no gravity. All right, so it's going to go out 65 cosine of 36, whatever that is, times t. You could find decimals for that. I just leave it like that. I don't have any rounding errors, right? All right, well, what happens with the y of t? Well, we have gravity pulling it down, right? So we're going to have our 1/2 gravity. What are we in? Are we in feet, meters? We're in feet, so we're going to do the negative 16 t squared, right? That's half of the negative 32. Plus, we would gain 65 times sine of 36 if it wasn't for the gravity pulling it down, times t. And it's on the height of the ground, so it's plus 0, right? So we're good. Those are our two equations. So we're trying to figure out what happens when he kicks this a total of 35 yards away. Okay, think about what we're trying to find. Can I find the time that it reaches the goalpost? How do I find the time, the number of seconds it takes to reach it? I could do this two different ways. I could find the height, like where it is horizontally after a certain number of seconds, or really I could say how many seconds to reach the goal horizontally, right? That's kind of what we're doing. So we're saying, well, when do I reach a total of 105 feet? And I set my 105 equal to my x of t equation. So when I have 65 cosine of 36, someone is blown up over there. Get lots of text messages. Snapchat, is that what the sound that Snapchat makes? I don't know. I don't believe in anything where a picture that you can take can go away. I feel like that's never a good thing. It's my own. That's mentoring from Mrs. Cox. If a picture can just disappear, it's probably bad. I don't know. And then everybody's like, well, I mean, you can see if they take a screen capture. Well, what are you going to do if they take a screen capture? You're going to go up and be like, please take that off your cloud. I don't know. Seems weird. All right. Anyway, I would really appreciate it if you took it off your cloud. All right. So I have 1.9967 whatever. I'm going to be a precise mathematician. What do you think I'm going to do? Store it. Store as alpha A. All right, now if I'm trying to figure out if he made this field goal, I want to know how high the ball is after that long, right? Because that's where it is horizontally at that time. right? I said, oh, at 105 feet horizontally, it took this long to get there. So how do I figure out how high it is? Yeah, now I find the height at this time. Right? So I'm going to plug it in here. So I'm going to find y of that a value that I just stored. So I'm going to have negative 16 times whatever I stored as a, right? 65 sine of 36 times whatever I stored as a. I'm going to feel really nerdy and my fingers are going to go really fast. Are you guys all plugging this in? You guys are faster. Your texting fingers. Snapchat fingers. You don't use your phone at all? Yeah. I never know where my phone is. It's usually like shoved in a couch cushion or something for my children. So if you text me, sorry, I'll get it eventually. All right, what do I have? 12.496 feet. Did you guys get that? Did you make the field goal? Yeah. You gotta be careful with hitting it too high though, Bill. If you hit it too high and they can't tell if you made the field goal, you don't get it, right? Did you guys know that? That's what happened several years ago in an IU Bowl championship. He totally made it, but it was too high. He was just overly ambitious about hitting it, I guess. And they didn't give it to us, and we lost the bowl game. So sad. All right, so it says you could also use your calculator or Desmos to graph these. Okay, so let's talk about graphing parametric equations on your calculator and why it's not the best. So get your calculator out. And I want you to go to mode. Oops, mode. Let me click on that. Well, actually, let's do it as a normal function first. So let's keep it in the regular function notation, this FUNC. And go to y equals. And remember how you can plug in. So we could do like negative 16x squared plus 65 sine of 36 times t, or times x, I guess. Let me make sure I'm in degree mode. So you can put that in as like a normal parabola that we've always done. And then hit graph. And it goes off a little bit. Right, so we can't see a lot of this parabola. So if you go to zoom, I always try this first. If you go to zoom fit, sometimes it gives you like the perfect thing. Sometimes it doesn't. Zoom fit works really well in AP stats, but it doesn't work very well here. So see what the issue is with zoom fit in this one. It's kind of giving us a lot of this like below the axis, and it's like, that's not the part of the parabola that I want to see. I want to see where it's above the axis. Does that make sense? So if you can at least get part of it, and then you go to zoom fit and you're like, oh, well, what if I did from, let's do like negative 10 up to, see how it was at a height of 22? Let's go even higher. So let's go up to like 50. And then you hit graph. Now our x values are at least the same. So those are still good. But now we can see more of that parabola. Does it make sense? Okay, and what is this parabola? This is like Bill kicking that football, and it's going up and coming back down. So if I wanted to ask you questions about this football, I could ask you what the maximum height is, right? And I could say, well, how high can he hit that ball? And you go to second trace and you go to maximum, right? Are you guys all doing that? And get on the left side of it and get on the right side of it and then hit enter. And so Bill would have kicked that ball up at a height of 22.8 feet, right? Do you guys see that? What if I wanted to find when it hits the ground? Well, I would do second trace intersect. And this is why when I did my window, I didn't start it at 0, because when you do the intersection method, you mean above the axis and below the axis. Or not intersect, sorry. I do that all the time. Do second trace 0, actually. Right, we're trying to find the 0. So we get on the left side of it, and we get on the right side of it, and then we hit enter. Right, and I could find that. Didn't we say it hit the ground after, well, I guess I didn't find when it hit the ground. It hits the ground after 2.387 seconds. What if I wanted to find how far horizontally it went after 2.387 seconds? What could I do? how far horizontally it's gone. This is the y function, right? This is finding our time, t. How do I find x? Yeah, I plug it back into this x of t equation. So I could go back to my main screen. You know what's cool? If you hit x equals, so x and then enter. So do that. See that number you just found as the intersection point? It's there. So you could say, oh, well, I could store it, or I could do 65 cosine of 60 or 36 times that x value. So I could do times answer or times x, it doesn't matter. And so it would have traveled a total of 125 feet, right? It's a really far field goal. Well, I guess it's not that bad. It's in yards, isn't it? So if I divide by 3, if I wanted to find how many yards that field goal was, it's still pretty far, 41 yards. Is that pretty far for football? I'm not very knowledgeable about football, but that's pretty good. All right, so that's the nice thing about using the function, like the things you've always known how to do on your graphing calculator. Now let's change it to parametric. So do this along with me. I want you to see what the good things and bad things are about this. Okay, so if I go to my mode and I change it from function into parametric, when I hit y equals, I now have my x and my y. Remember doing this before? So I want you to put your x of t equation, so the 65 cosine of 36 times t. And then the other one, negative 16 t squared plus 65 sine of 36 times t. And then there was no initial height, so just you can leave that off. You don't have to do plus 0 or anything. And then we hit graph. And so we're seeing part of it, right? And remember, this is, you know, Bill hitting this football. So how do we want to adjust our window? We go to window, and we want our x max to go out further. So you could do like 150, right? So we can see more of it. Does that make sense? Do you guys have the same thing, or do we need to adjust the window in other ways? Are you good? So my window for the t min is 0, and then it goes to 2 pi for the t max, which is kind of weird, but that's fine. And then I did x min is negative 10, x max is 150, y min is negative 10, y max is 50. You guys have that? Okay, so if I asked you the maximum height of this football in parametric mode, and I wanted to find that, try it. See how when you do second trace, there's not an option to find the maximum, right? It's kind of annoying. You can't find that maximum. But what you could do, the nice thing about this is you can trace, and every time you trace, it's going to tell you what's happening at a certain number of seconds. Now, here's the weird thing. As I hit arrow over, did yours do this? Mine says 0.130889, blah, blah, blah. If I go to window and I change that t step to 0.1 or even 1, and then I change this to like 20, if I go to graph, oh, it did not give me a good one, did it? I needed to make a smaller t step. 0.1, and I hit graph. That's going to give me nicer values, because now when I do my trace, so everybody hit trace, you have it as 0.1. Now when you hit arrow over, what happens? Oops, trace, arrow over. It says when t is equal to 0.1, our x is this, our y is this. All right, try to approximate it right there. So keep arrowing over. Are we getting there? It looks like it's at its maximum around 1.2. Is that as precise as we probably want it? No. But it gives you a good approximation, and the nice thing is it gives you the x value and the y value at that point. So it says, oh, our horizontal distance is 63, and our vertical is 22. All right, do you guys understand? Yeah.
Mine's just like a straight line.
You probably forgot your t squared. So if you go to your y equals, look for your negative 16. Does it say t squared on it?
Yeah.
And it just looks like a straight line.
Yeah.
So make your window go out further. Make the x max, did you make it 150?
Yeah.
Are you in degree mode? So mode, degree. Did you have your t after the 65 sine of t? Yeah. It's 65 sine of 36 and then t. And you have your t on the x equals as well? Yeah, I don't know. line in the wrong direction. Oh, I see. Oh, maybe not. Yeah, it was with your T step. So go to your window and make your T min and T max like 0 to 20. What that's saying is if I was doing a T table, I'm picking values between time 0 to time 20, right? And then this T step is saying if I was doing a T table, do you guys remember when we first did a T table? Let me write it up here. When you first did a T table, we did like T, X, Y. Do you guys remember that? It's saying if I start at 0 and I go up by 0.1, 0.2, 0.3, it's going to give me the X values for each of those. Yours was like set at like 20 or something. So it wasn't giving, it was only giving you like 2 values. Does that make sense? Yeah. Bill, did you have a question too?
No.
You got it. Okay. All right. So any questions about that? So you can go back and forth between the function and the parametric. And I recommend doing that on your homework, depending on what question it's asking for. If it's asking for a maximum, I would either do the negative b over 2a thing, right? Or I would graph it as a function and find that maximum using the calculator in function mode. Everybody with me? All right. The homework can be tricky, so don't get frustrated. You guys are able to do this. You can do it.